Okay, we're going to look over the quotient rule for derivatives. This is the only one we're going to focus on in this lesson. It states that if the greater function h at x is equal to the numerator's function divided by the denominator's function, then the derivative of h at x is derivative of the numerator multiplied by the denominator, subtract the numerator multiplied by the derivative of the denominator, and then our new denominator is the denominator squared. This will try to make a little more sense of this as we go through it. But in this case, I'm going to call, I really should call this h at, you know what, I'll call it h at x since that's what you guys are used to in those examples. If this is our f at x, and this is our g at x, and we're trying to find h prime x, or the derivative, okay, h prime x. That means what we're going to be doing here is we're going to take the derivative of h prime x first. So we're going to derive this function, and then just multiply it by g at x. Then we'll subtract it by the original f at x times the derivative of g at x, so the bottom, all divided by the bottom squared. Okay, so g at x squared. So let's plug these in one at a time. H prime x is equal to derivative of our top function here is what value? 1. That's right, it's just 1. Okay, so that's our top, and then our original g at x was 3x minus 2 squared. Okay. Subtracted by the original on top, which is x plus 5. Now the derivative of g of x is a little different. We have to remember to include our chain rule here. Okay. So that 2 comes down. We have our brackets 3x minus 2, technically to the power of 1. And then we have to multiply by the derivative inside of those brackets using that chain rule again. And the derivative inside the brackets is the number 3. And all of this is above what was originally on the bottom squared. So think of it like this. 3x minus 2 squared, and then we square that. Okay? So even though it was squared before, we need to square it again. Oh, I'm running out of room. Sorry. Okay. So this is our derivative. What we're going to try to do is simplify this a little when we go through it. 1 times this value would just be 3x minus 2 squared. Over here, let's multiply our coefficients first. So 2 times 3 will give us 6. So we're subtracting the value of 6. And then we're going to have x plus 5 multiplied by 3x minus 2. And on the bottom, we're left with 3x minus 2. And we have power of a power. We just multiply the two exponents, where we have to the power of 4. So in terms of simplifying, I want you guys to notice this. Technically, I have a 3 minus 2x on both of the terms on top. Okay? Which means we can eliminate at least one set of 3x minus 2. Here, if we eliminate one set of it, we'll only have one value left. And here, we'll have to subtract this by 1, so we'll be down to a third. So the new one will look like, and if you're very confused, I can go through that again. This will read 3x minus 2 minus 6 times x plus 5 all over 3x minus 2 cubed. So we did a little simplifying there. Think of it as if this 3x minus 2 was the value of y, think of it like we had y minus 6x plus 5, and then I had another y, and we had y to the power of 4 underneath. We just eliminated one of the y's from each of the terms. Okay. From here on top, we can do some expansion and maybe simplify the top of this. When we expand it, we'll get 3x minus 2 minus 6x minus 30. I do need to create a little more room again. The bottom or the denominator will still stay the same, which is 3x minus 2 cubed. And on top, we're going to end up with negative 3x minus 32 all over 3x minus 2 cubed. Okay? So this is our derivative. In the quotient, there's a lot of simplifying to do as we go through this. Okay? Here's our second question. We have a root function here. So what we're going to do in this question is the same as before. We're going to jump right to it. F prime x. We've got to find the derivative of the top function to start, so our f at x. Well, because it's cubed, we have to use the chain rule again. So we have 3 times x, 5x minus 8 squared. And then we have to multiply by the derivative inside the brackets, which would be the number 5. And then we multiply by our g at x. Okay? So this is the derivative of the top, and the original of the bottom is root x. Okay? And that is the whole first step. We then have to subtract by the original f at x, which is our 5x minus 8 cubed, times the derivative of our bottom. I'm just going to underline this in red. Now, the derivative of the bottom, what's the derivative of root x? Well, we can write it as x to the half, which means we'd have 1/2 x to the negative half. Okay. So this is what we're multiplying by, 1/2 x to the negative half. That's our numerator of our derivative. And on the bottom, we take what was originally there and we square it, so the power of 2. Okay, so let's kind of simplify what's in those brackets. F prime x is equal to, I'm going to multiply my coefficients together. So 3 and 5, so 3 by 5 is 15, times root x, okay, multiplied by our 5x minus 8 squared. Remember, associative property says that I can order these however I like. Okay? Now, this is where it becomes a little trickier. This part's obviously going to stay on top. We still keep our subtract the value of 5x minus 8 cubed. This part is a bit trickier here. Okay? If we're going to think about this, this value is a half, okay, which is very different, and this x is on the bottom. So there's two ways we can think about this. We can decide to split this to one denominator being root x squared and another one with root x squared. And if we do that, then we can work with these values coming down to the bottom of the equation and changing things. Or we could just leave it as is and try to simplify from what we have. And simplifying from what we have is relatively difficult here. Okay? So what I'm going to do is I'm going to split this to see if it'll make it a little simpler for us into two different terms. When I split it in two different terms, we have a half. Well, a half can be written as just 2 on the bottom of this term. Okay? And this x to the x to the power of negative a half is the same as just root x on the bottom. Okay? That still needs to be multiplied by, and now this, what is this going to become when we square our root x? Just x. So x here, and it still has to be down here on the other side too, because we split the equation. Are we okay with this step? Yes? No? Maybe so? Okay. So what we have now is we have two different denominators. Okay. Which means if we want to combine this into one function, we need to make our denominators the same. So in other words, because this denominator has a 2 root x multiplied by the x, this fraction here I need to multiply by 2 root x also. So let's do this. We'll multiply the top and the bottom by 2 root x. So let's see what this becomes. F prime x. When I multiply 2 by 15, what do we get? 30. Yes. And root x times root x is x. Not x squared, but just x. 5x minus 8 squared. Okay. Minus what's on the top over here, which is 5x minus 8 cubed. And now our denominators are the same because of what we did in the last step. So it can all be written over 2 root x times x, or in other words, 2x times root x. Okay? We look around, is there any way we can really simplify past this? What else could we do? We could take a common factor out. That's probably not imperative. There's nothing we can really do with eliminating from the numerator and the denominator here. We can't take an x out because we don't have an x outside over here. We can't take a 2 out unless, well, if we did, this would become a half over here. Okay, so whatever we eliminate from one of the terms on top, that's equal on the bottom. We have to eliminate from the other term like we had done above. So this is a somewhat simplified form. We can expand. Expanding is somewhat helpful. But essentially, this is our derivative. We could do a couple things from here. We can expand and simplify. We can... I think expanding and simplifying would probably be the best step from here. That's a long process. And this is fine for what we need it for. This is our derivative in this question. Okay? So quotient rule. A lot more to calculate when going through.